Hello, everyone. Welcome to the Decisions. Is data analyst the right career for you? Um, I'd like to first introduce myself. I'm the moderator for today. Most people call me Sadiq because the first name is very hard to pronounce. Um, so yeah, I am a senior financial analyst and data analyst. Um, Currently working from Ohio. Um, I pursued a master's in finance from Boston College, and I'm here to be a moderator. I'd like to introduce the panel for today. We have Jonah Lashin, head of data operations at DataVant. Jonah is a PhD, so we should address him accordingly, Dr. Jonah.
Not necessary.
Well, Jonah received his PhD in math in 2014, decided to go into academia, but decided otherwise and branch into data science to learn more about business and how it relates to the organizations. Fun fact, Jonah is a very big NBA fan. Jonah, what team do you support?
Celtics, all the way.
Okay. Next, we have Lydia. Lydia is a data scientist. Lydia has a master's and an undergraduate degree from Cornell University, where she studied operations research and information engineering. So yeah, Lydia is a very smart lady. Fun fact, she likes reading so much that during the quarantine, she ordered so many books from the Boston Public Library that when they opened up, they had to ship them in a crate to her. So that is one thing you should know about Lydia. Next, we have Daria. Daria is a machine learning specialist at Posh Technologies. He has been working in machine learning for a couple of years, previously a data analyst, and then shifted to machine learning. Fun fact, Daria co-founded social impact nonprofit City Awake, which was acquired by the Chamber of Commerce and the Fierce Agency of Now Festival. So there is one thing you should know about Daria. There you go. And then we go to our last panelist, which is Natalie. Natalie is a recruiter for executive search leader for the Amazon Group. She was previously at Wayfair, and before that, she worked in Liberty Mutual Insurance. Fun fact, Natalie has been a hedge fund recruiter for over 7 years. How rare do you meet people like that? A recruiter that has been recruiting for hedge funds. I mean, it's hedge funds. So yeah, there is one thing to know about Natalie. So yeah, we're gonna jump right into the questions. So we are all here to learn about data analytics, data science. It's been going around. What is it all about? So yeah, I'm gonna jump in and put it to my panelists. What is data science? What makes one a data professional? Who is going to take the first crack at it?
Teddy, so I'll actually jump in and go first because I toyed around with the definitions. And I have a complex definition and a simple definition. And I think it's better to move forward with the simpler definition, which is it's somebody that's really good at understanding and diving deep into data to make things simpler, easier, and better for the end consumer. And when I say the end consumer in today's world, be it in the startup world or the large corporation world, it could be really anybody. It could be your customer. It could be somebody that is on the supply chain team. It could be somebody in HR. But there's a variance of customers that you're looking to essentially comprise that data and deliver it in a digestible format. And so in my mind's view, a data analyst, be it a data scientist or a data engineer, really is looking to make things simpler and better.
Okay. Well, I didn't know that. So Daria, you've been working in the data profession for some time. What can you tell us about that?
So I think that's a pretty good definition of data science and data analytics. I think another useful kind of way of thinking about it is that you have really kind of descriptive versus prescriptive work. So descriptive work requires you to kind of think about the patterns of data that you see in observations, whether it's sales behavior, whether it's user click-through rates, whether it's chat patterns in your chat logs, whatever it is. But you're kind of looking through the data historically and trying to understand like some patterns that emerge. And then you have prescriptive work, so you're basically trying to make predictions. So this could be like recommendations. This could be like building out conversational AI functionality for a chatbot. This could be image classification or whatever it is. But kind of your work kind of spans in two different ways. You either look back historically and try to understand what's happened, or you try to look forward and try to make predictions so that a customer can engage with your product or your use cases in a meaningful way.
From my personal experience, I really have no idea how predictive and forecasting really works. Looking at what you're saying, I guess there is a correlation over there. So Lydia, I see you've worked with data science for a couple of years now in health and startups. How does it work exactly over there?
Yeah, sure. So what my company right now does is we get just big data dumps from health plans. So we are in charge of everything from how to ingest that stuff, how to clean it, how to process it. Healthcare data isn't famous for being the cleanest in the world. And then how to look at it, kind of see what population you're dealing with, see what kind of populations you want to help. And then from there, build predictive models on it so we can refer the people who need the most help to the programs that can help them. So we're just kind of in charge of that whole pipeline. And that's why I'm interested in this field, and especially in a startup, is because you have a very different day every day, like depending on where in that process you currently are.
That is wonderful. That is very wonderful. We've all talked about data science, what data science is. There are so many, I personally have come across so many titles for so many data professionals. We have data engineer, we have data scientists, we have data analyst. So when you enter the data field, what are some of the specializations? How do you move in a data environment? Me being a data scientist or being a data engineer, is it the same thing we all do as a data analyst or a machine learning specialist? Would Dr. Jonah like to take this one?
Sure. And I think it's worth noting that the same titles at different companies can mean different things. You'll see data scientists can often is like a catch-all term that could be, building machine learning models, kind of building data pipelines and data engineering. At other companies, data scientists might be more kind of ad hoc data analysis. So I typically think of the roles themselves as there's, kind of model building, machine learning, and then and these aren't necessarily discrete. There's like a continuum that kind of extends into then kind of putting those models into the product, into production, and that gets into kind of data engineering, even, software engineering, depending on how you're going to deploy. There's also kind of more client-facing roles, which you'll be responsible for, create data visualizations for the client, often communicating with business stakeholders, presenting work. So kind of data science to me is kind of fairly broad in that term. Data engineer, I think, is a little bit more clearly defined in terms of moving data around. And then data analyst, I tend to think of as more closely supporting business operations and more kind of like ad hoc analyses.
That is interesting. With what you said, is it a one size fits all where one can actually do one's work, or are there specializations involved, specific specializations?
I mean, each of these kind of has their own like kind of specialization depending on kind of how deeply you want to go into them. There's, I would say, for people early in kind of in the process of getting into these fields, there are common, tools that are valuable across all of kind of all of these, I guess you could say like subspecialties. There's some familiarity with databases, with data visualization, with automation. So kind of each of those, I think, is important fundamentals to have, and actually I think all too often gets skipped over. People kind of, there's a tendency to want to jump ahead to kind of doing the fanciest thing to start out with, which maybe could impress some interviewers, but I think generally you're kind of better off starting with the fundamentals.
Yeah. So from Natalie, from a recruiting's perspective, you've recruited product managers, you probably recruited data analysts, data engineers. When you're recruiting something like that, when you're putting out those requirements online, what do you actually look for in every role?
Sure. So to kind of touch on Jonah's comments, and that's precisely it. I think the career tracks has delineated quite a bit in the industry over the last 10 years. And now the fields, even with data science, vary quite a bit. So, you could move into data science, but you could specialize in natural language processing. You could take the machine learning track. You could you could essentially move into more of a data engineering track, and then that splits even further into applied analytics. And then if you get into a broader company, the tiers split based on where exactly in the customer journey you're facing off with the customer to. But I think that the underlying theme for all these roles is that there needs to be super strong fundamental programmatic requirements. Typically when you interview for any of these positions, depending on which language the company runs on, there's going to be an assessment test to see how proficient you are in Python, SQL, MATLAB, and the like. And then I think that differentiating factor for data science and applied analytics is that there's a enhanced element of critical thinking and solutioning, versus data engineering tends to rely a little bit more on productionalizing and cleaning that data. So Lydia, I'm sure that she probably has a ton of experience with this, but what we found is that the industry has evolved and there's so much data right now and it's all super messy. So there's a little bit of a grittiness in getting into this and being able to split the data, clean the data, and then overlay it with solutions so that the end consumer could actually use it. And in the large company setting, that typically is multiple career tracks that are working on one specific problem, versus in the startup world, that tends to fall to kind of one person to wear many hats. But the fundamental skill sets are all very much there and the same. It's just a matter of where your interests lie over time and what you enjoy over time.
So from Daria, from your experience as a machine learning specialist, how has that been?
Like in the general context of like doing machine learning work, or?
Okay.
Oh, sorry. Yeah, just like in general, in terms of like what the work entails, or like the experience. Okay.
How has it been for you looking at evolving from a data analyst to a data and machine learning specialist now? How has it been like for you?
Yeah, I mean, I think so. Regardless of kind of what your specialization is, I think there's a broad level kind of understanding. So I think like the further you go down in the pipeline, like you need to be a good data scientist, be a good machine learning engineer or machine learning kind of researcher. In the work that I do, a lot of it is kind of having really good intuitions about the data that you're working with. And so, a lot of my work requires me to kind of have, a better understanding of both language and also, distributions of language, depending on the domains that I'm working in, before, I even start at looking at building a model, or start at building out functionality for whatever use case that we have. And so, I think there's fundamental skills that you kind of transfer, like Jonah was talking about, whether it's, basic data analysis, basic kind of district stats, whether it's kind of, looking at whatever domain you're in and kind of diving deeper into that. But having good intuition, I think, is really important. And then for the actual machine learning, right, it really depends on the problem space you're working on. I feel privileged to be actually working on some pretty cutting edge things. So oftentimes the problems that we work on are pretty correlated with where where academic research is right now. So the majority of my work tends to be looking at looking at papers that are coming out of academia as well as contribute to that academic space around work that we do with especially conversational AI. So we're looking at kind of, doing language modeling and very complex use cases for keeping track of conversation state or keeping track of, what the user is asking in kind of, variable domains. And so it's been kind of fun to be able to keep abreast of stuff in the academic space. I know that other roles I've worked in, that's sometimes not the case. It really depends on the problems that you're working on. So sometimes, it's a pretty low bar, and you really, just a simple kind of regression model or simple kind of decision tree will get you out the door. And so, depending on where you are and the types of problems you're working on, the solutions you have could be complex, could be simple. And really the challenge is kind of how do we wrangle the data that you have, which is always oftentimes unstructured and unannotated and all over the place, and put it into a meaningful form that you can, do something productive with.
Yeah, sounds good. So yeah, I'm very proficient in Excel. Over the last 10 years, that is all I've been doing. I'm very proficient in Excel. Does that make me a data analyst, or do I need to have some special tools or have some knowledge of some special tools like Python or SQL to become a data analyst? In Lydia, your everyday work where you go and you do data science stuff, what tools do you use and what skills are very necessary to accomplish your daily goals?
Sure. Yeah. Excel is great, but Excel has, unfortunately, a size limit. So you tend to hit a ceiling at a certain point if your data set is too big. On a daily basis, we run everything in the cloud. We have everything on AWS, and we do all of our data processing in Spark Scala. So you really want to take advantage of the fact that it can process a lot of data really quickly. So we actually write most of our code in Scala, but then if we want to build deep learning models, those aren't the best on EMR. So then we spin up separate, like really big EC2 instances, and we write all that stuff in Python. We actually use PySpark. And then we port it back over into our Spark Scala stuff and reprocess it there. We kind of have two different environments for stuff.
And just jumping off that, another, I think, critical difference between Excel and some of these coding languages that, when you code something, you have it in kind of a reproducible format that's kind of easy to share, easy to modify, so kind of what the status was at various points in time.
Here I thought I was data analyst because I knew Excel. That thought just went out the window.
I think that's the wrong way of framing it, right? I think data analysis refers to a set of skills that you have in terms of the intuitions and the methodologies in which you analyze data. The tools you use can be irrelevant, right? They're really dependent on the tasks that you have at hand. So if you're a financial analyst who's looking at spreadsheets, you're still a data analyst because you're working with data and you're working on, analyzing your data for patterns, forecasting out, or whatever kind of work that you're doing. People do some really kind of crazy things in Excel, so it's really impressive. Airtable is a software that's funded on the idea that you can basically build software around an Excel as a database. Usually the limitations you run into Excel is just that it's not super connective to kind of other pipelines and other processes that you have. So you end up essentially using different time data formats, whether it's a SQL table or whether it's a JSON representation that you pass to other processes. Then you kind of use Python or use other scripting code to include together. But regardless of the tools that you use, what makes data analyst a data analyst is the actual ability to analyze data. So I don't think it's tool dependent at all.
Well, I guess the data analyst is back. Yeah. So over the past couple of years, we've seen data analysis or the data science field expand. We've heard of big data, we've heard of IoT, we've had a whole lot of machine learning. What has the trend been over the past 10 years, and where do you think is going to be going into the future? I think this is a question for Natalie. Natalie will take a first shot at it.
Okay, I'm not sure if I could answer the latter part of the question, which is where it's going into the future. I'm sure that the data scientists on this call would be able to answer that better than I can. But I could speak to the field historically. And this is one of my favorite topics because I think that data science has kind of become the buzzword and as Jonas pointed out, kind of the catch-all for for the field. But in fact, it's not new at all. I mean, there was always mathematicians coming out of top tier universities and plugging into various different elements of our society to be able to produce predictive modeling results and applied macroeconomic theory. I think that really the field expanded, which is what is exciting about it today. When I initially started recruiting for an executive search firm, you alluded to the fact that I recruited for hedge funds. That's actually where I would say that data scientists were applied in the infancy stage, where essentially analysts started to build out quantitative models to be able to filter through tons of companies to essentially assess what type of models those companies have, how likely they are to grow or to decline. How can you quickly assess, 100 companies instead of reading through a financial statement of every one, then get down to the 10 that you actually want to analyze based on your sets of criteria. Now, that obviously in some cases worked out, in some cases it didn't because of the subprime market. The models didn't catch that glitch, and ultimately a lot of hedge funds in Boston specifically blew up. But in terms of the actual technical skill sets, they were all very similar. Now, I think what's interesting is as you're moving into the industry and specifically in the tech world, a lot of the same mechanisms are applied, but you have a lot more systems, tools, and platforms to be able to house large bunch of data, manipulate it, and look at it from a different perspective to be able to make business decisions. So that's the most exciting thing, is that it expanded beyond financial services, it expanded beyond hedge funds, it expanded beyond the academia. And, you're ultimately, or rather the e-commerce market for specifically is the byproduct of that expansion. We continuously see iterations of our experience online, and that fundamentally comes from those companies studying large amounts of data. So that's kind of the most interesting thing. Now, where it goes into the future, I think that's probably up for debate. I know that there's quite a lot of debate around compliance and data storage and everything that we see in front of Congress these days. And I think that there needs to be some sort of a regulatory piece that protects the end consumer. But I think that's something that we'll probably see change and shift over time as well.
That is interesting. Jonah, would you like to tell us how you see the data science field emerging in 10 years from now?
It's a good question. I think it will probably kind of continue to become more specialized within these different subdomains that we were speaking about, and also kind of the tools go hand in hand with kind of the roles, because kind of new tools, right, allow you to do kind of new things. 10 years ago, before, or however many years ago before AWS existed, there was working as in data was entirely different. So my thought would be probably kind of continued emphasis on AI, and then just kind of some of the kind of the engineering kind of capabilities that you get with some of these cloud providers, I think are going to allow people to work with kind of larger and larger volumes of data. So I mean, those would be my high level thoughts.
Yeah. Lydia, what do you think?
Yeah, I think even in the few years I've worked at SIFT, everything's just gotten easier and faster to do, and all of the processing power has gotten faster. So the kind of like the models are getting better. So I think just everything is like going to start accelerating more and more, but we're still sticking on like the data ingest part and then like the data visualization part. So I think we're going to see like more attention paid to those ends, because I think the middle is kind of easy to keep optimizing and keep running with, but like we're going to be we're going to hit a bit of a bottleneck if we can't get the data in the right formats to go through those pipelines. So I think there's going to be more attention paid on those, like the ends of the pipeline instead of in the middle where a lot of it is now.
That is very interesting. I look forward to seeing the new technical terms that they come up with for all those things you mentioned about the outputs and the inputs. I know there is definitely going to be some fancy names for all those things. Now, when we look at
mind if I also jump in on that question?
Come in.
Mind if I jump in on the question as well? I'd
Yeah,
love to
sure.
provide a perspective from the AI space. Because I think there's actually a lot of interesting things that are happening in the AI space. So like I think as Lydia kind of pointed out and Jenna pointed out that a lot of problems are becoming solved. So I think like a lot of low-hanging fruit, whether it's classification or it's like very simple kind of regression problems. Your models are pretty powerful, especially with deep learning. Essentially any arbitrarily deep learning model should be able to pick up the underlying representation of what your data is. And so I think what's happening now is that you're seeing move towards some more, a lot more interesting kind of problems that are emerging as a result of that. So like on the business side, I think like, business is starting to actually slowly catch up to where the academic space is, because oftentimes academia is ahead of enterprise usage of these technologies. And so I think what's kind of exciting is that like language, for example, right now is having its moment that Vision had about 10 years ago with the advent of CNNs and the ability to basically run CNNs on GPUs and make them tractable. With pre-training and like large language models, you were basically able to do some really miraculous things that were unable to do, prior to it, prior to like 2015 or 2012. And so one, it's really exciting. I don't know if you've seen things like GPT-3, where you can basically, have it, create stories, write blog posts, make websites, do all sorts of really cool things. But a lot of that capability is driven by this idea of having like really large pre-trained language models. And so as a result, I think like our ability to kind of work on both discriminative as well as kind of classification problems is becoming readily solved. And what's happening as a result is now people are moving towards like even harder problems in the space. So as we kind of look at where AI is moving, you're moving towards generative problems. Like how do we, for example, generate novel things? Can we create, movies based on descriptions of it, or can we create new text based on, a simple prompt? There's really interesting work that's kind of also happening at the lines of unstructured data. So a common kind of limitation for most enterprise use cases is that you need to have lots and lots of labeled data, because most of your machine learning models require you to have annotated examples, and they, exploit the fact that you're able to find, underlying patterns based on the labels that you have. But the challenge, like, probably this Lydia has seen, is that like, and probably Jonah has seen as well, is that in most enterprise use cases, you don't have labeled data available to you. And so if you're trying to find insights, or you're trying to build, any sort of predictions off of unstructured data, you're kind of at a loss. Like, whether you use top-up modeling or like just very simple kind of clustering, it requires a human expert to come in and make sense of those clusters that are being generated. But there's some really interesting work that's kind of emerging now, where like, you have zero-shot learning, and you have kind of like, really interesting representations of unstructured data that can be then used as soft labels for downstream things. So you have like some really cool kind of work that's emerging as a result. So like, it's worth keeping an eye out on things like, weakly supervised learning, things like zero-shot learning, things like, adversarial generative learning as well, because all these kind of areas are moving towards a world in which we don't need to have large amounts of labeled data. We can kind of just take in anything and throw it into the model and produce some really interesting outputs. And as kind of that technology emerges, it becomes easier to use, you'll see a lot more interesting business use cases that emerge as well.
That is very interesting. So just jumping into the next question, as our time is almost up. We're going to look at, so on a corporate environment, me as a finance major, when I look at a corporate environment, when I enter the role, I know I'm starting as an analyst, I'm going into an associate role, and then hopefully climb the ladder, the corporate ladder, to maybe a VP, a partner or something. How does that translate into the data profession? Do you start as a data analyst and transition into something else entirely? How does that work for both the corporate environment and the startup environment?
Sure. So Jonah, you go ahead.
Okay. So I was just going to say, I think there are multiple paths you can take. If you start out as data analyst or data science, you can kind of proceed on that track and become more and more advanced, and kind of more and more technically sophisticated, work on more and more difficult problems. And there's also the path, and these aren't necessarily mutually exclusive, of getting more into management and, kind of thinking about what problems should be worked on, overseeing the work of others, and kind of moving more on the business side. And, oftentimes, right, the CTO of a company is not necessarily even touching the code, depending on the size of the company. So I think there are a couple different paths depending on kind of your preferences.
Yeah, and it's not kind of interesting because I've seen a shift in the industry recently where specifically in the analytics and the sciences field, even all the way to the senior level, companies are looking for people that could still review the cases, review the code, not necessarily write code because that tends to happen at the more entry junior level. But in order to kind of course correct a strategy, they actually have to understand what the production of that code is and catch abnormalities. And it's specifically kind of speaking to Wayfair. I've only been at Amazon for a little while, but specifically speaking to Wayfair, the executives there go really deep into the production models and are able to then kind of set the team on the right trajectory. And even at the I guess director level, there's a field that's being defined, the principal level field, and that tends to happen both at Amazon or Wayfair and in other companies where you have really senior professional individuals that are right there on the ground with the analyst class. They're still very much in the weeds, and companies tend to benefit more from people that are kind of like at the higher up managing everyone and people that are actually on the ground and understand the work. And I think that's going to become more prominent over time because you really don't need, 10 organizational data science manager leaders unless you're leading super massive production lines that tie to X amount of revenue. You need people that could really stay close to the technology and understand what's relevant. And that is particularly, I've seen this shift in this in the last 5 years where you kind of get away from the management track and get closer to people that are actually industry deep dive experts.
So yeah, for Lydia, for you being in the startup space, how has that evolution been for you?
Yeah, so I see there's kind of two different types of startups data scientists would start at. So it's either a company where data is part of its core offering, in which case you would kind of start in that core offering and grow as the company grows. And then the other kind of startup is they're in a different space, but they've acquired enough data and they want a data scientist to start helping them. You usually start in sales and marketing because those are the disciplines that just kind of naturally produce data. They're tracking their numbers for all these different things. So they'll usually have tables for you ready to go. So then as that company grows, you can either continue in sales and marketing and advertising and that whole space, or you can move into different sectors and maybe supply chain or whatever the company's in. But those are the two paths I usually see.
So from what I gather, there is no specific trajectory for moving in the startup space. You just go however the company expands.
Yep, you kind of go with the company.
And it's not too different from a larger company as well. I mean, you might start in one specific discipline and then another discipline is spinning off and you've proven yourself to be a leading expert and you get tapped for the next project. I think that it is really product-based and project-based work, and agility is kind of key to developing your career in the sciences field.
Okay, sounds good. Before we take in our audience questions, do you need to have a specific degree or have some master's level certificate to be able to enter the data science field or be able to apply for a data science role?
Yeah, I could take this one because I think I probably got the weirdest background. I was an English major, studied creative writing in college. And then, I worked a lot of weird jobs. I was a business analyst, I was a project manager before kind of, shifting into data science and then eventually into NLP and AI research. And so the short answer is no. I think you come at it from different backgrounds. I think the key is really kind of building up a lot of the skill sets that you need. And so I think if you're taking an entry into foray into data analytics, having just a good understanding of summary statistics and just kind of a good analytical understanding is really important. Oftentimes, where people are really successful is they have really good deep domain knowledge about a specific thing, whether it's, supply chain optimization or it's sales or it's whatever thing that your company is doing. And then you kind of pick up additional skills to, kind of make sense of that data. You can make different kind of pathways. The transition from kind of going into from analytics into kind of data science and more predictive analytics, as well as kind of machine learning and AI will require definitely a little bit more sophisticated understanding, but there's different kind of ways of getting to that. I think one of the cool things about machine learning and AI work is that it's highly conducive to experimental and empirical work. And so if you're able to run experiments and you're able to kind of build up intuitions by playing around with models and playing around with like problems, you can kind of gain the insights and then kind of augment it with like, additional learning on the side to kind of get a better understanding of, how to build these systems out. And I think the key thing is just understanding kind of what is it, the domain that you're working on, and having good deep domain understanding of that. And then the rest of the things kind of fall into place. You can learn the skills that you need to kind of be successful. So there's definitely different ways to kind of different credentials and different paths that kind of get into the space. You don't necessarily have to have a PhD, right, in math or applied stats to do data science. Also depends on the role that you're applying for too. So.
And I would jump here as well. I completely agree. I think that when you're recruiting out of school, my peers in campus recruiting, it's just a way for them to enter a school and scale a program. It's just an easier way to say, okay, we have this track available for you. And if you're interested, apply, and you typically get an assessment test. And if you pass the assessment test, you move on to the various parts of the interview. But you could equally apply for the role, get the assessment test, pass the assessment test, and move on to the interview. I think that this is one of the probably the few fields in corporate or business setting where tech depth and analytical rigor comes above everything else. And I think more and more really companies stop caring about what pedigree you're coming from and more of what you're able to do and can use solution.
From Jonah, what has been your experience like?
Yeah, I agree in terms of that, kind of the degree that you have in school, kind of the first thing I would say is that kind of once you're in the job, I feel like, that stops mattering, and it's more kind of, how you're performing at the job than, what your prior background was. I suppose if you're going to something extremely niche and, you want to be kind of up to date on the latest academic research, then, an academic degree clearly speaks to that. But generally speaking, kind of when I've interviewed and looked for roles, I actually lean towards more in kind of the major is, I won't ignore it, but I will kind of give more weight to, kind of what are kind of outside projects that the person has done. If they have previous job experience, what did they do in their previous job? Yeah, I agree that there's so much also kind of online learning. Like if someone can demonstrate that they've spent 1,000 hours taking online courses and has expertise, to me is just as good as a degree in the corresponding field.
That is amazing. That is amazing. I mean, from you coming from a typical mathematics background where everybody expects you to have some idea or some experience in data manipulations and data statistics, that is a very interesting insight. Yeah, so we would like to jump onto the audience questions. There's a ton of questions out here. So I'm going to start with the first one. Does COVID-19 have an impact on the pre-existing machine learning models and possibly existing data sets? And how is it going to be different after the pandemic?
Yeah, I'll take this one. It's definitely different. We didn't even have a code for COVID-19 before this. So like we have a feature that doesn't exist in any of our previous models. And I changed my healthcare behavior. A lot of other people changed their healthcare behavior. And one of the kind of fundamental assumptions is that the past is going to look similar to the future. And that's kind of how machine learning works. So it's definitely a big concern. I'm also concerned about building models over this period of time because it is dramatically different than it has been. But yeah, if you have any ideas, I'd love to hear them.
I think for every company, it's just such a unknown period. And from my 5 minutes of onboarding at Amazon, I think that there's a lot at work here to kind of understand what exactly are the implications to the market. Amazon also brings in a lot of academic scholars that are right there with you to try to understand exactly what is the impact to the end consumer. And the only thing we could really do is create products and value to the customers during an unknown time in the what if scenario. And I think that's really, it's a big giant unknown factor at the moment. At least from the folk that I've hired into economist disciplines as well. Like they sort of have a giant question mark. I don't think anybody tends to put their name on the line to say like, this is what it's going to be for the next 3 to 6 to 9 months. Like no one really knows.
Yeah. A bunch of uncertainties going around. Daria, how has it affected your work, and what do you think is going to happen after the pandemic?
I mean, that's really disrupted our work cycle. We've been pretty successful in moving to kind of remote. I think the nice thing about working in a tech startup is that people are pretty used to kind of working wherever they are on their code and on their kind of their research. So I think from our point of view, since we have a primarily tech offering, it hasn't been super different. I think going forward though, it probably will affect, at least from a startup point of view, a lot of the impact is more business and financial. So like, I know for us, initially we had a challenge where we're running into kind of customers freezing their budgets and not buying products. But we also happen to work in a space that lends itself really well to providing remote automation and remote capabilities for companies around conversational AI. And so as a result, there's actually been a huge demand for our product. People want to use chatbots, they want to use smart IVR systems to offset the lack of employees that they have manning the phone lines or manning the support lines that they have. And so ironically, COVID's actually been really good for our business model. We've actually had, we've doubled our waiting list of customers who want to jump on board to using our product. But that's definitely not the case for other startups. I mean, I know like startups both in terms of their business as well as their funding have run into challenges. So we'll see what happens in terms of the long run. I think there'll be definitely a slew of really interesting product ideas that unfortunately got killed because they just happened to be in the wrong place at the wrong time.
Yeah. Jonah, would you like to add anything?
I mean, I think, we've experienced regard to the so also kind of working at Datavant, which kind of helps companies in the healthcare space exchange data, right? We've also seen the kind of an influx of new kinds of data, and in some aspects, the healthcare data has become kind of increasingly kind of important, and also I think visible in the kind of broader public domain. And then as we're just talking about the kind of the business impacts, some of them have been difficult in terms of budgets for for buying data for doing certain projects.
It has been definitely an interesting time. On to the next question. I really don't understand this question, so yeah. What is your opinion on the quite popular nowadays HR analytics world? What is your experience with the domain, and is there any difference from the normal data analytics?
I'll just say one thing: don't build a startup around the space. It is a terrible idea. My previous startup tried to build this as their key market, and one of the challenges you run into if you're building a startup is that most HR departments are not empowered to buy your product. Usually they're sourced by the IT department, and IT departments usually have much different funding and much different kind of strategies than oftentimes the HR department does. And so if you're trying to disrupt the space or try and move into the space, you will have a really hard time getting tractable customers. But aside from the business point of view, I think that like there's some really interesting work to be done. I think there's definitely a lot of stuff around people operations, around interesting kind of use cases where you're tracking employee learning and success, as well as kind of employee development from a data-driven point of view.
I think to your point, it's a really interesting field, and it is very much dependent on the culture of the company that you're coming from, and specifically how visionary and amped to change that HR department is. Coming from the two companies that I worked with previously, I think that there's a ton of appetite for data. And as a matter of fact, the role that I'm in now and the role that I was previously, everything was measured. And we recognized our limitations, and there was a lot of data created tools to kind of solve for some of these problems that were super clunky. And then there was a large investment into understanding how do you create tools and mechanisms that are available to everyone so that you can make sound decisions. One of those tools was a platform to help with diversity and inclusion initiatives. And how can you really make and bridge diversity initiatives when you really don't understand what your population looks like, what your attrition looks like, and what elements is your attrition attrit in a diversity spectrum. So I think the companies that are going to invest, to your point, and take the biggest strides are the ones that are going to probably bubble up to the top of the market, because they do understand that understanding the people that work in the company is critical for the success of the company. And then lastly, being able to, measure the impact and the quality of the individual that's working for your organization, especially if you're driving the bottom line. That's very important. How do you quantify that? There's a lot of gaps, and I think this is one of the fields that I think data analytics and data science has a fantastic runway, because it is relatively unsophisticated and there needs to be a lot of work that goes into it.
Lydia, do you have anything to add to it?
I think that covers it.
Okay. On to the next question. This is directed purposely for Jonah. As the head of data operations, how do data analysts generally interact with each other and with other company departments?
Yeah, so I would say the kind of interact with one another, kind of reviewing each other's code, helping one another kind of debug certain things, just kind of general teamwork with other functions in the company. There's maybe a few different categories, and again, these aren't kind of drawing like a hard line in the sand or anything, but one kind of thing which in some ways can be the most challenging is ad hoc requests from like executives or folks on the business side who kind of want a very specific question answered, and often in a timely fashion. And so job as a data analyst is to kind of do your best to support those requests. And when you see kind of patterns in the requests, to try to kind of build something that can be self-serve, a dashboard, or just an updated spreadsheet, so that these kind of popular questions that come up are readily available. Product is another area where data scientists and data analysts would kind of interact a fair amount in terms of helping inform product with regard to design questions that rely on kind of the data that you would work with. So kind of what are the costs of working with the data in terms of financial costs from technical infrastructure, level of effort, and then kind of bringing ideas to product that it may be the case that to build out the spec of a certain product exactly as it's written would be very difficult, but to approximate it, within, kind of 1% of say accuracy is maybe, much easier. And you as a data person might have that knowledge and be able to bring something like that, which is quite valuable. And then there's kind of visualizations to be made for, for sales efforts. There's interactions with, kind of IT and security to make sure that you're compliant, perhaps even interactions with a legal team around compliance, which I believe, as Natalie mentioned, is becoming increasingly more of kind of an issue that's being discussed at companies.
And to add to that, it's actually when you're talking about what do you look for in a resume in the analytics field. That's that element of scrappiness that I think that makes somebody successful, to be able to push in an executive and say, okay, I know what you're asking, but to build a model that could tell you what you're asking is going to take me 6 months. So let me work with other departments to figure out if you can kind of give you a production model based on static data versus active data, and be able to explain things so that the business leaders understand in not layman terms, but kind of like explaining it as if you would to your mom, if you will, so that they understand why you can deliver on something, immediately, and why there is limitations. I subsequently, I also supported our infrastructure group at Wayfair, and that's another big component, because you need to be able to get funding for the technology for which you house the data, and that's another conversation. So it's kind of being able to effectively communicate and be scrappy, but then be able to push back effectively to be able to do the work that you're doing and deliver on what your promise is without all these distractions. I think it's very challenging.
It's definitely interesting. We are on. We have about 7 minutes to go. I'm going to take the last question. Being a graduate industrial engineering student, although I have learned Python with all the other tools involved, that is the pandas, the matplotlibs, and what have you, the R, the SQL, but being new to a field, I do not have projects to showcase to my co-op employers. How does a student like me with no experience in significant projects enter the field of data science?
So I think there's two ways. One is build a portfolio for yourself, right? So there's a lot of data sets available out there for you to play with. Go to Kaggle, go to data driven, find a data set or find a challenge that looks really interesting and just kind of play with it. Two is when you're looking at entry level positions, kind of look for positions that might not have the word data scientist or data analyst in the title, but have responsibilities. Like for example, my first job in data science was actually had the title research analyst. So like when I was working at Harvard, I was working with the senior leadership team, doing strategic consulting and providing strategic consulting to senior leadership at Harvard. The interesting thing about that team was that I was actually the only non-academic person. So that team was mainly PhDs, ranging in backgrounds from economics to particle physics to apply stats, and I was actually the technical person coming into that team who had a really strong Python in our background. And so the way I was able to differentiate myself was I was actually not an academic, but I had a strong technical background that was able to do kind of a lot of the data analysis and data visualization work that they're looking for. And so oftentimes when you're looking at job descriptions, look for things that are looking for that kind of speak to the skills that you have and see if there's opportunity to match there. And then, like I said before, build a portfolio. So, find a really interesting thing. When it comes to also building a portfolio, look for things that are kind of unique to you and passionate to you. Like I think if I see another like Titanic data set, or if I see another, Iris data set kind of example, I'm going to probably go nuts. So like try to choose something that's not standard, right? Like go for it, or, like New Sentiment or whatever it is, like do something that's kind of unique to you, whether it's like, hey, fantasy football, or like, looking at like COVID cases across the United States, whatever it is that you find like really interesting. Just spend some time, build a portfolio, kind of asking yourself those exploratory questions and using the tools that you have available to you to like do some interesting data analysis work and have that as part of your portfolio.
And just jumping off that, in terms of the portfolio, at least I'd be curious to hear the other panelists' takes, but when I'm kind of looking at someone's portfolio projects and applying for a job, I'm much more interested that they kind of clearly laid out what they're doing, that they're using the right kind of techniques to solve a problem, and that things are kind of written in proper functions when they need to be functions, as opposed to kind of just a really long Jupyter notebook that with and it's kind of not clear what's going on, and they've maybe used really fancy things and maybe they did everything perfectly, but as kind of someone looking for candidates, right, we don't have 2 hours to try to parse someone's code, and also kind of want to kind of be able to demonstrate that your communication skills, written communication skills, are going to fit with or kind of are basically up to par for other people to understand your work.
As we approach our last 5 minutes, I would just like to put this question out there. Any last advice for anyone in the data field or in the data science field, somebody about to enter the data science field and somebody thinking of leaving the data science field? What is any advice you would give to them, or any areas they should explore before they should exit?
I would say that set your expectations of what a data scientist is aside, because it varies quite a lot, and be prepared to have it be kind of like an all-encompassing career journey. Data science, if it's in a vacuum and you're not scaling your work and you're not influencing through your work, is irrelevant. You need to be able to work with a variety of folk in the industry, across business peers, to be able to influence so that people could actually see the value of what you do. And it's not purely a head down role for a kind of quintessential introvert. You have to kind of get yourself out of that box and really dive in and learn what the problems are and be able to solution for that. So those are the people that I've seen be the most successful and the most influential, and they're the ones that are the most passionate about the work and excited about the work. And I think that if that's you, that's absolutely the great career path. But if it's you don't want to talk to people and you want to be purely on analytics, it's not the field to be in.
Yeah, and I think there are a lot of tools or like tutorials out there that kind of do a disservice in terms of the image that they present as kind of what the skills that are needed, and they don't get at those things that you're talking about, Natalie, which I certainly agree are kind of most important.
Any last takeaways from you, Lydia?
Yeah, just be really excited about this field. It's really cool. We get to predict the future with math, and just like dig into how the math works. Sometimes people come to interview and they don't really understand what the mechanisms behind it are. So like it's really cool that like you can write something, but if you don't understand what's going on behind it, like could break in weird ways. So the whole thing.
Any last words, any last messages?
Sorry, a couple of things, right? One is be T-shaped, so have kind of a broad background where you have some basic skills across the board, whether it's analysis, whether it's coding, whether it's communication and data visualization, and then kind of specialize in an area that you feel kind of particularly interested in. And usually T-shaped kind of things become more in demand as you kind of grow up your progression ladder. So you start off kind of broad and you're working on lots of different problems, but as you find a specialization like you want to work on and get interested in, whether it's scaling, whether it's machine learning, whether it's like, data science for health applications, whatever it is, and you start building domain knowledge, that becomes helpful in terms of progressing in your career. And the second thing I think I find really interesting is focus on problems and not jobs. So oftentimes I think people are like, I want to be a data scientist, or I want to be a data analyst, or, whatever it is, like, and they look for titles. And the challenge is that like half the times these, these jobs will not exist in 10 years, or they might change and be completely different. Like if you were to ask someone, 10 years ago, what a data scientist is, they probably wouldn't have been able to tell you, this is a thing that you do. And so I think what's really helpful is finding really interesting problems that you find yourself kind of compelled to and driven to, and kind of diving into those problems and understanding what makes those problems really unique, whether it's the data that's involved, whether it's the complexity of representation, whether it's the, the use cases in enterprise or whatever it is, but find really interesting problems to work on. And you kind of use that to kind of guide you where you go in your career.
Thank you so much for coming to the panel. Thank you so much for making the time to speak to our audience today. We really appreciate your time and your commitment. And to the audience, thank you for making the time to listen to us babbling on about machine learning and the data field and what the complexities and the sophisticated words that you have to Google tonight to understand some of the things we mentioned here. So thank you for coming. And Chaya, would you like to take it away?